Hi, it's Kevin Lebates here, and I noticed that last week Vitalik Buterin was announcing a whole roadmap for Ethereum over the next 2 to 3 years, a very ambitious one with lots and lots of components to it. It's a bit like trying to dismantle and rebuild an airplane engine while you're flying along, but to be honest, the Ethereum team have shown that they're actually very, very good at updating, modifying, and in some cases replacing components of the system while keeping it running. So if anyone can do it, I do believe that they can. The one thing that I want to talk about in particular today is Vitalik's pronouncements on quantum security. So I'm sure you've all seen all the reports about how quantum computing is just around the corner and that it's going to shatter the effectiveness of things such as the elliptic curve digital signing algorithm and other digital signing algorithms and various cryptographic methods, and that this is going to be very, very bad for blockchain as well as a whole bunch of other industries, and that something needs to be done to address it. And initially Vitalik was talking about how we're going to use zero knowledge proofs or Starks to replace these digital signatures. Problem with those is they are extremely large, and I noticed that in his recent talk he switched to talking about hash-based signatures. Now the interesting thing about hash-based signatures is that they're actually very, very old. Leslie Lamport came up with them in 1979. They're also very, very large. A Lamport signature is about 16 kilobytes, I think, if I can remember correctly. Anyway, in my book that is going to be coming out very shortly, called Smart Contract Innovation, I have a whole chapter that goes through the problem of quantum security in a post-quantum age and the problems with the existing digital signing algorithms that we have that are quantum resistant. I also look at a hash-based replacement that is approximately twice as large as an ECDSA signature, which is significantly smaller than all the other options out there. And I couldn't find a specific hash-based signing algorithm that Vitalik was referring to. So if any of you can find that, please do leave a comment below. I'll keep looking myself. Maybe I dozed off in the middle of the speech. It's quite possible. But anyway, interesting stuff. It's nice to see that Bitcoin and Ethereum are really starting to get vocal about the importance of being ahead of the curve when it comes to quantum security. I still think they're leaning too much into the we'll use quantum secure digital signing algorithms that are already out there, because honestly they really are orders of magnitude larger than current signatures, and we will end up with blockchains that are 99% signatures. And certainly we can't continue to pull the trick that Bitcoin did with segregated witness by saying signatures will only count for a quarter the size of the space they take up, because that would involve something like segregated witness where you say that a signature's weight is 100th of what a transaction is, and it starts to look ridiculous. So as I said, anyway, great stuff. Nice to see that a prediction I made about 2 years ago, that hash-based signatures were going to be the way to go rather than something like dilithium crystals or Sphinx, which are just either too computationally intensive or too large, or both. Who knows, maybe somebody will come up with a fantastic new quantum secure signing algorithm that is the same size as ECDSA, although to be honest, in the time frame that we're looking at, I think that is unlikely. And then the remaining challenge really is to come up with an aggregation signature scheme to replace BLS, which is currently used in attestation in Ethereum, although my gut feeling there is that what they're going to do is reduce the number of attestations that are required in a block to overcome that one. So I hope those of you interested in following quantum security issues have found this video interesting, and maybe some of you who are not may still have found it interesting, and I'll see you in the next video soon. Bye for now.